So first we're going to recap how we simplify radicals. If we have the square root of 54, we want to break it down into any perfect squares that we can see. If you're not sure what perfect squares work, you can just use your trees and break them down. So 54 breaks into 9 and 6. Now you can use any pair that works. 9 breaks into 3 and 3. 6 breaks into 3 and 2. We're looking for pairs. We have a pair of 3s. So a 3 is on the outside. And then I have a 3 and a 2 left. I multiply them and I get 6. So 3 radical 6. So same idea with the 96. So we're going to break down 96 into whatever you can think of. So 3 and 32 works. 32 breaks into 8 and 4. 8 breaks into 4 and 2. 4 breaks into 2 and 2. And 2 and 2. Now remember, you can't use the numbers that have like branches coming from them. So you can't use 96, you can't use 32, you can't use 8, 4, or 4. So that narrows down what you're looking at. Again, we're looking for pairs. We have a pair of 2's here. We have another pair of 2's. So since there's 2 pairs of 2's, we're going to multiply them together and get 4. And then we have a 2 and a 3 left, so a 6 on the inside. All right, 27. We have 9 and 3, and 3 and 3. So you have a pair of 3's with a 3 left over. Okay, and then 125, 25 and 5. 5 breaks into 5 and 5. So we get 5 radical 5. So we kind of covered this in the quadratics chapter, and we're going to continue with it and kind of delve a little bit deeper into it. So we're simplifying radical expressions today. And right now we're just kind of recapping what we talked about before. So square roots of variables. We basically did this exact thing earlier. So we're just going to kind of go quickly through this one. If you have an even exponent, so if I have the square root of x squared, I'm going to have x. The square root of x to the 4th is going to give me x squared. The square root of x to the 6th is going to give me x cubed. So as a general rule, we can say the square root of x to an even is going to be equal to x to that even divided by 2. So for instance, if I have x to the 50th, I'm going to divide 50 by 2, and I get x to the 25th. And these values go outside of the radical. They're not in the radical anymore. When you have an odd exponent, like the square root of x cubed, this would be x radical x. The square root of x to the 5th would be x squared radical x. The square root of x to the 7th would be x cubed radical x. The square root of x to the 9th would be x to the 4th radical x. So our rule for this, x to an odd, that's going to be equal to x to the odd minus 1 divided by 2 radical x. And what I mean by this is that you can't divide an odd number by 2 evenly, so you subtract 1 to make it an even. So for instance, I'm going to look at this one. If I have the square root of x to the 9th, I can rewrite this as the square root of x to the 8th and the square root of x. This one, square root of x to the 8th, now follows my rule for even. Since 8 is even, 8 divided by 2 is going to be 4. And then I have this square root of x left over. So if I had the square root of x to the 25th, I want to take this, and I want to take 1 away. So it would be 24, but then I have 1 left over. So I'm going to take that and divide it by 2. So I have x to the 12th divided by x. Okay, so you don't need this step here, the square root of x to the 4th square root of x. I'm just doing that to show you how you're breaking it down. You're just taking your odds, so 25 minus 1 is 24. 24 divided by 2 is 12. So x to the 12th is outside, x is left over. Okay, so we're going to look at a couple of these. So when you're given something that has more than one thing under the radical, you're going to just break them down separately and then smush your answers together. So you have the square root of 81 and the square root of x to the 4th. So square root of 81 is 9. Square root of x to the 4th is going to be x squared. So your answer is going to be 9x squared. Okay, same thing here. Square root of a to the 8 is going to be a to the 4th. Square root of b to the 18th is going to be b to the 9. So my combined answer, a to the 4th, b to the 9. Okay, so these ones get a little bit trickier. Again, same idea. Square root of 27, square root of a, square root of b cubed. So square root of 27 is 3 radical 3. You can use your trees to break that down. Square root of a is just going to stay square root of a. So if the exponent on the a, which is a 1, if it's less than your index, which is a 2, it's just going to stay the same. Square root of b cubed, we have to subtract 1, so 3 minus 1 would give us 2, and then divide that by 2, and that gives us b to the 1st on the outside with 1b left over. So now we're going to put these all together. Anything on the outside stays on the outside, anything on the inside stays on the inside. So we're going to have a 3 and a b on the outside, and then we're going to have a 3ab on the inside. Okay, so same thing here. We're going to break each one up. So if we take the square root of 81, that's going to give us 9. Square root of x to the 3rd, so we're going to subtract 1, so it's 2, divided by 2 is 1, with 1 left over. When it's odd, you're always going to have 1 left over. So square root of y to the 4th is even, so it's going to be y squared. Z to the 6th is even, so we're going to have z cubed. So outside we have a 9x y squared z cubed. Inside we have an x. Okay, so here's more of the same type of example. I will let you guys figure these out, and I will post the answers to these later on. All right, cube roots with variables. So a cube root has an index of 3. So if I have the cubed root of, so that little 3 there, that means it's a cubed root. It's my index, which is a 3. So if I have the cubed root of x to the 3rd, this is just going to give me x. If I have the cubed root of x to the 6th, this is going to give me x squared. If I have the cubed root of x to the 9th, that's going to give me x cubed. So basically the rule is that if I have a multiple of 3, as my exponent, I'm just going to divide it by 3. So it's going to be x to that multiple of 3 divided by 3. So if I have the cubed root of x to the 36th, I can divide 36 by 3 and get x to the 12th. If I have a number that's not a multiple of 3, it's sort of the same as when we had odds with the square roots. So, use a different color. If I have the cubed root of x squared, this is going to stay exactly the same as the cubed root of x squared, because your exponent is not equal to or greater than your index. So whenever your exponent is less than your index, so 2 is less than 3, it's going to stay the same. If I have the cubed root of x to the 5th, 5 can't divide by 3. It's not a multiple of 3. So the closest multiple of 3, without going over 5, is 3. So 3 divided by 3 would be 1, and then I have 2 left over. Okay, and you have to write that little 3, that index of 3 every time, so we know that it's a cubed root and not a square root. Okay, square roots, we don't have to write the 2 because it's understood. So if I have the cubed root of x to the 7th, okay, so 7 can't divide by 3 evenly, so the closest thing, without going over, would be 6. So 6 divided by 3 is 2, and then I have 1 left over. So the rule is pretty much like x to the not multiple of 3. You have to bring it to be an x multiple of 3 divided by 2, and then you're left over with the cubed root of x with whatever's remaining. REM for remaining, I don't know. Okay, so let's kind of look at that one again. So we had the cubed root of x to the 7th. So we can bring this to be the cubed root of x to the 6th and the cubed root of x, because x to the 6th and x is going to be x to the 7th. Since 6 is a multiple of 3, 6 divided by 3 is going to give me x to the 2nd, and then I have this x left over. Okay, so that's how I got my answer. So if we look at another one, the cubed root of x to the 29th. Okay, so my closest multiple of 3 would be 27, and that means I have 2 left over. So the cubed root of x to the 27th, 27 divided by 3 is going to give me 9. So I have x to the 9th, and then I have the cubed root of x squared left over. Okay, so if we look at these, for example, again, same thing we're going to do. We're going to break each one up. Okay, so you don't have to do this if you understand this, but if you want to keep everything separate and make sure you're doing everything you need to be doing, it might be a good idea to break things up. So 12 is a multiple of 3, so I can divide it, and I get a to the 4th. 15 is a multiple of 3, I can divide it, I get b to the 5th. So a to the 4th and b to the 5th. Okay, as far as numbers go, you can have a negative inside. That's fine. You can have a negative with a square root, but you can have a negative with an odd index. So whenever I have a negative, that just means that I'll have a negative on the outside. So the number itself, we're going to break down with our trees. So 125. The way you break down numbers for cubed roots is pretty much exactly the same as you would a square root. But now instead of looking for pairs, you're looking for groups of 3. Since the index is 3, we want 3 of the same number. So 125 would be 25 and 5. 25 would be 5 and 5. Now you need 3 of the same. So here's 3 of the same, and there's nothing left over. So I have a negative 5 on the outside, and then a cubed, since that's a multiple of 3, it's going to give me an a on the outside. Okay, so let's look at the last one here. So 128. So let's make a tree for 128. So 64 and 2, 8 and 8, 4 and 2, 4 and 2, 2 and 2, and 2 and 2. So when it gets kind of crazy like this, you might want to X out things you can't use so you know. So I can't use 128, I can't use 64, I can't use 8, I can't use 8, I can't use 4, I can't use 4. So what you have left is you're looking for groups of 3. So I have 3 2s here. I have 3 2s here. So same rules apply. I multiply them if they're the same. So a 2 comes out from my group of 3. Another 2 comes out from my group of 3. So that's going to be a 4 on the outside. I'm left with this 2. That's by itself. So that's going to go on the inside. So that's what the cubed root of 128 equals. It equals that. So then we do the cubed root of x to the 7th. 7 is not a multiple of 3, but 6 is. So 6 divided by 3 is 2. And then we have 1 left over. So we're going to smush it together. On the outside, we have a 4x squared. On the inside, we have a 2x.